Okay, I'm just going to take a look at the sum and difference of cubes and when we want to factorise these sorts of things. The type of thing that you might be looking for is two things which are cubed, like I've got here. It could be something like 2 cubed minus a cubed, or 2 cubed minus x cubed, or whatever. So I'll go 2 cubed minus a cubed as an example. And when we're doing this, we identify what I call the first bit, or the first term which is cubed. So in this case I'm looking at the 2. And the second bit we might identify as the a. Okay, so the first thing cubed, take away the second thing cubed, or it could be the first thing cubed plus the second thing cubed. When it's take away, it's a difference. When it's plus, it's the sum. Now, if we look at the general rules which are provided here, the first one, if we have x cubed take away a cubed, then for the general rule to plug in, we have x minus a in the first bracket, excuse me, and the second bracket x squared plus ax plus a squared. Tricks to help you remember these: if we have the take away there, then the take away goes into the first bracket. If we have plus in the question, then plus goes into the first bracket. Then if you look at the second bracket, all of the terms are the same in the second bracket, in the quadratic bracket, but you would take the opposite sign is the first sign that you would encounter. So like if it's take away, then plus is first. If it's plus, then it's take away, it's first. Otherwise, the two rules are essentially the same. So looking at this example that we've got here, 2 cubed take away a cubed, this is going to be the difference, so it's the first of the rules which is there. So the first bit is going to be 2 take away a for our first bracket. Then for the second one, it's going to be 2 squared plus 2 times a plus a squared. And it's always good if you've got a 2 squared that you would actually evaluate that. So we just write this as 2 take away a, 4 plus 2a plus a squared. Okay, we'll go on with some more examples here. In this case here I've got 2 examples. The first one there is x cubed take away 27. And we need to identify that we are actually dealing with the difference of 2 cubes. And if you look at the 27, we can actually rewrite 27 as 3 cubed. So I'm going to say that this is equal to x cubed take away 3 cubed. So now, as I said before, we've got our first bit, which is the x, and the second bit, which is the 3. That's what I'm calling them anyway. Equals. Look at the rule. So this is a difference of 2 cubes, so we need to deal with the top rule. So the first bracket's going to be x take away 3, and the second bracket will be x squared plus ax, so that's going to be x times by 3, and the last part of the second bracket is going to be 3 squared, and then I'll just rewrite this, simplify it, so it's x take away 3, x squared plus 3x plus 3 squared is 9. Okay. And the next example that we have here, I'll just draw a little line through there so that we can differentiate what's going on. So this is MP all cubed plus 8, so we can rewrite this as MP all cubed plus 2 cubed. Now this is going to be using the sum of 2 cubes rule, which is the second one up there. So this will be equal to, in this case, the first bit from the general rule, which is the x, we're going to treat as everything inside that bracket, so that's MP, the whole lot of it. So the first bracket will be MP, and this is a sum, so it's going to be plus, and the second bit is 2, and then for the second bracket we write MP all squared take away mp times by 2, and plus 2 squared, like so. And then I'll simplify this and rewrite it. So it'll be equal to mp plus 2. And then for the second bracket, what I'll actually do is expand out that bracket, so it's going to be m squared p squared, take away 2mp, plus, and 2 squared is 4. And that one's factorised. Okay, we'll move on to the next example. Okay, the first one here, we'll need to simplify both of these terms, write them as cubes. The 8x cubed is equal to 8 is 2 cubed, so it's going to be 2 cubed x cubed plus 64, which is 4 cubed. Then I'm going to rewrite this again so that the first term is all cubed, so it's just going to be 2x all cubed plus 4 cubed. So we need to be dealing with the second of the rules that's up there. So this will be equal to x plus a from the general rule, so that will be 2x, which is from the first bit, plus 4, and then the second bracket will be 2x squared, take away 2x times by 4, and then it's going to be plus 4 squared. And I'll just rewrite this as simplified, this second bracket there, so that'll be equal to 2x plus 4. Second bracket, the 2x, we need to make sure that we square everything inside it, so it's going to be 2 squared and x squared. So that 2 squared is 4, x squared, take away, and then we have to go 2 times 4 is 8, x, plus, and then we have 4 squared is 16 for the last term there. And for this last example, again, we need to simplify this. So this first term, 27, is equal to 3 cubed. So I can just rewrite this as 3p all cubed. Take away 125 is 5 cubed. So 5q all cubed. So this is dealing with a difference of 2 cubes, so we use the top rule up here. So then we can write that into the 2 brackets. So the first bit is 3p, take away, the second bit is 5q. And then for the second bracket, we need firstly 3p squared, and then it's going to be plus 3p times by 5q. And then for the third bit, it's going to be plus 5q squared, and that needs to be all squared for that 5q. So then I'll just simplify this again. So it'll be equal to 3p take away 5q. And then we have to make sure that we square the 3 and the p, so 3 squared is 9p, plus 3 times 5 is 15, pq, and then for the last bit, 5 squared is 25, q squared. And that's the answer to that one. So I hope you find these useful. Have fun.